Hey, algebra, here's what I do now. We got two lines with some cool navcats on them. We're going to find the slope of each of them. Go ahead and hit pause while you work that out. Hey, so the green line has got a rise, goes up 2, and a run to the right of 3 spaces, slope of positive 2 over 3. The blue line is going down, so we're going to give it a negative slope. It goes down 3 spaces and right 2, so negative 3 halves. We're going to keep rolling. We got a number of graphs to find the slope for. So here are two more lines. Please find the slope of these two lines. Hit pause while you work this out. All right. Hey, so this green line has that same slope, positive 2, and to the right 3. And the blue line here also has a slope of positive 2 over 3. It's got a rise of 2 and it goes to the right by 3 spaces to get to that next point. All right, last graph, find the slope of these two lines. Also, please hit pause while you find these slopes. Nice job. So this green line up 1 space and right 4 to get to the next point, so positive 1/4 for the slope. And the blue line down 1 space and right 2 spaces, so negative 1/2. Today we're going to look at writing equations of perpendicular lines and parallel lines, and that is a topic that we're going to be working on for several days. So today we're just going to take that first step. Our learning target is to be able to find the slope of perpendicular lines and parallel lines. And we'll build in the rest of writing equations in the coming days. But today, we're just focusing on the slope. So regardless of which form of an equation we use, whether it's slope-intercept form, y equals mx plus b, or point slope, y minus y1 equals m times parentheses x minus x1, or even the standard form down here at the bottom, ax plus by equals c. We need to find the slope out of any of those forms. We won't be writing the equations today, but we do need to recognize where slope can be found. So a couple of definitions to start with. We need to define perpendicular and parallel both. So perpendicular lines are lines that intersect at a 90-degree angle. And if we were measuring things with protractors, 90 degrees would be a perfectly good way of determining whether lines are perpendicular or not. However, in algebra, we tend to shy away from the graphical approach, and protractors and rulers and things like that is more like a geometry kind of thing. The way perpendicular is defined on an algebra perspective has to do with their slope. Slope is a description of direction for lines, and the slope of perpendicular lines, you can see this in the box here, are opposite reciprocals. And let me demonstrate what that looks like. In the first part of our do now, the slope of the blue line was negative 3 halves. And the green line on that same graph was positive 2 thirds. Okay, opposite reciprocals means the sign will be opposite. So we can see here one is positive, one is negative. Reciprocal means that the two parts of the fraction have traded places. The rise and the run are switched. The numerator and denominator have traded places. So the blue one, 3 is on top, 2 is on bottom. And the green one, those are switched. 3 is on the bottom, 2 is on the top. Parallel lines are lines which never intersect one another. And again, if we were in geometry or using protractors, we could measure the angles and make sure that they both point in exactly the same direction, but we're not. So in algebra, the way we measure direction of lines is on the graph. We're going to have to find the slope. So parallel lines in the box down there, parallel lines have the same slope. It means they're going to have the exact same rise, the exact same run, both going up or down depending on whatever they're doing. So from the second part of the do now, numbers 3 and 4, the blue line had a slope of positive 2 thirds, and the green line had a slope of positive 2 thirds. Jumping back to our do now briefly, the first pair of lines we saw on this first graph were perpendicular. The slopes have the same numbers in there for the rise and run, but the rise and run are switched, and the green slope and the blue slope have opposite signs, so they are opposite reciprocals. The next pair of graphs we saw were parallel, exactly the same slope. Both go up 2 spaces and right 3. And the last pair of lines are neither parallel nor perpendicular. They're just two lines. They do intersect, they cross, but that doesn't make them perpendicular. They're only going to be perpendicular if they intersect at exactly 90 degrees. And these two lines do intersect, but that is not 90 degrees. We can know that by looking at the slope, positive 1/4 for the green one, negative 1/2 for the blue one. While one is positive and one is negative, that's true, but they do not have the same numbers for rise and run at all that have been switched or otherwise. They have different slopes and there are different lines. Okay, let's recap. Perpendicular slope, we have to do two things to identify perpendicular slope or to create a perpendicular slope. First, we have to change the sign. One line is going up with a positive slope, the other will have to be going down with a negative slope, so opposite sign. The second is we need to do the reciprocal. Reciprocal, and that's a big math word. It just means that we're going to switch the numerator and the denominator, or we can think of it in smaller words than that. The rise and the run trade places. So instead of the two on the top in the green one, it's going to be the two on the bottom in the blue one. And in the green one, the three is on the bottom. So in the blue one, it'll switch. Three is on the top. Parallel lines have the same slope. Two different lines in different places on the graph, but they both go the exact same direction, like we saw in the do now. So positive 2/3 on the green line, positive 2/3 on the blue line. Here's some examples about finding, creating, identifying slope. What is the slope of a line parallel to this green highlighted equation? Y minus 4 equals negative 3 times parentheses x plus 2. Well, in order to find a slope that's parallel to that, I'd have to know what is the slope in this green equation. The slope is right there between the equal sign and the parentheses, so that is negative 3. If I'm going to make a parallel slope, it'll have to be exactly the same. So parallel slope would be negative 3. What if I want to find the slope of a line perpendicular to this green highlighted equation? So this equation is written in a different form, y equals mx plus b. But in order to answer this question, my first step is to identify what's the slope in that green line. Well, the slope is the thing being multiplied onto the x. In this particular case, it is right next to the equal sign, but more importantly, it's the one multiplied onto the x, positive 2/5. To do a perpendicular slope, I need to make these two changes. Opposite sign, so since the green one was positive, the blue one will be negative, and I need to do the reciprocal. Rise and run, trade places. So 5 on the top, 2 on the bottom. Just for good measure, let's do another couple of examples here. What's the slope of a line perpendicular to this green equation? It's the same green equation we saw before in point slope form. Y minus 4 equals negative 3 times parentheses x plus 2. But we need to identify the slope out of the green line first, negative 3. In order to find the perpendicular slope, I need to make those two changes. So change the sign. The green one was negative, so my blue one will have to have a positive slope, and then I need to do the reciprocal. Well, in order to do the reciprocal of this slope, since it is a whole number, I'm going to rewrite that green slope as a fraction, so I'll just put it over 1. Down 3 over 1. That's the green slope. Now I can see the rise and the run to do the reciprocal. I'm going to change around or trade places with the rise and the run. So positive 1 on the top, 3 on the bottom. Okay, what's the slope of a line parallel to y equals 2/5 x minus 3? Well, I need to identify the slope in this green equation first. Positive 2/5, it's the number being multiplied onto the x. Parallel lines need to have the exact same slope, so no changes, positive 2/5. Our last example comes from some coordinates of points rather than equations. So in order to do the same type of identification like we just did, we're going to have to find the slope first. So given below are descriptions of two lines. Line 1 goes through the points 6, 7, and 0, 5. Line 2 goes through the point 0, 6, and the other point is negative 110. We're asked for the slope of each of those two lines first, and then we compare them. Are they parallel or perpendicular or just not either of those two things? So we're going to start with line 1, 7x and a y coordinate, and x and a y coordinate. So I'll need to subtract y2 minus y1 over x2 minus x1. So let's do this. I'll go 7 minus 5, and then 6 minus 0. Subtracting across the top, 7 minus 5 is 2, and across the bottom is 6. And then I'm going to reduce. That's 1 over 3. And just for clarity later, that's a positive slope. For the second line, oh, let's write that in here, 1/3. You don't actually need a plus sign, but I'm going to keep it there just for clarity. The second line, so I got an x and a y, an x and a y, so I'm going to subtract again y2 minus y1 over x2 minus x1. And so let's go like this. We'll do 10 minus 6 on the top, and then -1 minus 0 on the bottom. Let's subtract across the top first. That's 4. Subtract across the bottom. -1 minus nothing, still -1. This time I can just divide. 4 divided by -1. It's going to give me a slope of -4. All right, and now I can compare. So option number 1, line 1 is parallel to line 2. That is not true. They would have to have exactly the same slope, and they don't. Option number 2, line 1 is perpendicular to line 2. Well, in order for that to be true, those two requirements would need to be met: opposite signs, which they do have, and the reciprocal, or the rise and the run traded places. And that is not the case here. The rise and the run, which the green one and the blue one, are totally different numbers. So it is not perpendicular. Option number 3, land 1 is neither parallel nor perpendicular. It's like none of the above, right? And so that's the option I would choose for this example. Not everything is parallel or perpendicular. Those are the two special cases that we're looking for, but a lot of times lines just are lines, and they have different slopes, but they're not parallel and they're not perpendicular.